Okay, so I would say we can start. Can you all hear me and see the slides? Yeah, perfect. Okay, so welcome everyone. This is the free training for the Research Methods and Statistics 1 for the first interim. I'm Alessia. So just to very quickly before starting the meeting, I would kindly ask if you could turn on your camera. So obviously we are not in person, so it is a bit hard to interact, but it could be nice if I could also see some faces and not just black screen. And we are not that many people, so it's always kind of nice if we can try and make it a bit more interactive and personal. So if at any point you can turn on your camera, that would be very much appreciated. Thank you so much. Okay, so just to very quickly introduce myself before we actually move on to the statistics. I'm Alessia, I'm Italian. I studied psychology and then I studied sexology. I've been teaching mainly statistics for the last 5 years and I work at the Gay Center in Rome. Why am I teaching statistics, you might wonder? Well, sure, for example, here I got a good grade for the course, but actually because I'm one of those, so I do happen to love statistics. Now, I don't think a lot of you feel the same way, but I hope that by the end of the course and everything, you might hate it a tiny bit less, or at least you didn't feel like you could have done something else in life. So we shall see. I hope so. And before we begin, I don't know if you noticed, but there's a WhatsApp group, so you can scan the QR code. This is like the here general chat. So also after the course for the rest of your bachelor, if you're ever gonna have any questions, you can always ask there. You also received an email with a link to like a specific chat for this training. So if you have any further questions, you can ask them there. And in that same email, there's also a link to the Google Drive where the presentation will be posted. And from what I understood, in this WhatsApp group, they will also send a summary. So of everything that we're going to cover today, you will receive a free summary. So pretty handy. Okay, so what is going to be the structure? And this is also the structure of every course you will find at Athena. So it is statistics, but obviously there's also a theory part. For some people, good. For other people like me, horrible. So if you like more the math part, then bad. But if you don't really like numbers, then good. And after the theory, we're gonna see some examples together. So just to try and understand what it actually might look like at the exam. And then we're gonna try and see some exam questions. Okay, so what are you gonna need today? If you can have next to you pen, paper, and the calculator or your phone, but make sure you have the calculator for the exam itself. So you will have to do some calculating stuff. Okay, I saw something in the chat. So before we begin. Yeah, the slides will definitely be shared in the Google Drive, but if anyone struggles with that, I think they can also be shared in the group chat probably. So I will definitely ask for it otherwise. Okay. So just to give you an idea, so here's like the chapters of the books that you have to study. And this is an exam analysis. So basically they took previous year's exam and they try to understand how much of the things from those specific chapter get asked. So you can see that, for example, here, chapter 5 is pretty much asked. So it might be worth it to spend more time studying that one than others. And today, these are the ones that we're going to be covering. So I know it's a topic that a lot of the time students struggle with. So just to give you an idea, this is what we will see today. And maybe looks familiar, maybe no, but it's something that's pretty important for research and statistics. So by the end of today, hopefully we are able to name what we are seeing in this slide and also distinguish them. So for example, what kind of question you might want to be able to answer after today? So let's say that you get at the exam a question that's like, aliens have landed on Earth, and it turns out they're pretty chill. Mario befriends some aliens with the goal of using them to further his own research career. As a first step, he decides to measure their IQ. you observe the following scores: 122, 145, 167, 169, 180, 181, and 195. And then they might ask you, what is the standard deviation of this set of observations? So by the end of today, we will know, well, first of all, what standard deviation means, and then how to calculate it. Because it is very likely that at the exam, they give you, just like here, a little bit of a description, some numbers, and then you have to calculate the standard deviation. So one of the goals of today is being able to answer this question. So we're going to come back to this by the end of today's session. Okay. So at any point, if you have any questions, obviously feel free to ask. You can either unmute yourself, you can type it in the chat, you can use whatever emoji reaction, and yeah, and then I'll try to answer your question or maybe give some further example if anything is not clear. And if you feel like I'm going too fast or too slow, also that, always welcome any feedback that you might have. And because we don't have much time today, so today we only have 1 hour and a half together, so I'm just gonna do one quick break, more or less in the middle of today's, of around 5 minutes. But once again, if you feel like you're already devastated but just that 45 minutes of statistics, which can be pretty fair, then we can also have 10 minutes break. So whatever you will prefer in the moment. Okay, so what is gonna be the planning for today? We're gonna start looking at what statistics is, and specifically, we're gonna look into the data and the distribution. Okay, so let's start with the data. Now, first of all, what is statistics? So before we can understand the components, we need to understand what it is in general. Well, statistics is just the art and science of learning from data. So we have a lot of data, which could be numbers, the IQ scores of people, and we want to be able to understand these numbers. So if I just see a page, an Excel file, or whatever that's full of ones, 173, 3.5, they don't mean anything to me. With statistics, we can understand what exactly these numbers mean for us. And there are some main components, such as the research design. So basically, the framework, the blueprint for a study. So how do we want our study to look like? And it helps us then decide on how we are going to collect the data, which analysis we're going to do, how to interpret the numbers that we have in order to answer our research question. So the research design, basically everything we're going to do, all the steps, kind of like an instruction guide. So which construct we're going to have, how do we operationalize them? So let's say we want to investigate depression. Okay, but it's not so easy to just see depression. We don't really walk around the street and be like, oh, I see depression. Oh, depression. What we can do though is maybe create some variables that we can measure. So we might look for some behaviors such as, I don't want to get out of bed. I don't really enjoy meeting with my friends anymore. I don't want to eat. So all those things that we can observe, and that eventually will help us measure depression. So those are parts of the research design. Then we make a big distinction between two types of statistics. We have descriptive and we have inferential statistics. Okay, what is the biggest difference? Well, with descriptive, we want to describe, as the name is saying. So we are just going to try to summarize and explore data. So we have a lot of numbers, a lot of data that we have collected, and we just want to understand what is going on. So we want to... I'm gonna mute it. Okay, so, and whenever it's descriptive statistics, we are talking about samples. So if you look here, we have a whole population, for example, all the women in the world. That's the population, just women. A sample could be the women in the Netherlands. So we want to use a smaller group that's representative, though, of the whole population. Then, what is then inferential statistics? Well, inferential statistics is the fact that once we have data on our sample, hopefully we would want to generalize the conclusion to the whole population. So with inferential statistics, yes, we work with a tiny part of the whole group, but just because we want to be able to make conclusions about the whole. It's just very hard to have data on all the women of the world. It's pretty impossible. So what we do is that we're gonna work with just some women and hopefully be able to make conclusions about all the women in the world. So we use it to learn from the data and make predictions and indeed generalize. So descriptive, we just have a sample, so a part of the whole population, and we just focus on that data. That's it. While with inferential, we have the sample, but we want to make conclusions about the whole population. So we have a tiny group, but eventually we want to be able to talk about the whole group. Okay, so a statistic is just a numerical summary of the data. So we have a lot of data and a statistic, which could be a Z-score, which could be a standard deviation. We're gonna see all of them, is just a summary. So with that single number, with that statistic, we are able to summarize the data. For example, the mean. So the mean is a way to kind of summarize the data. So the mean helps us understand that on average, let's say students of the psychology bachelor score a grade of 7.5 for these course. Okay, that's a summary. So it more or less helps us understand what is going on. And it can be represented with a number. So like here, we can calculate with a formula, and the mean could have been 7.5. 7.5, it's a number, or with a graph. So whenever we're going to see such a thing, this is also a statistic. So statistic can be number or a graph. Now, the descriptive. So we said that the descriptive statistics are a summary of our sample. So not the whole population, but just a part of it. So not all the women in the world, but just maybe the women in the Netherlands. And we want to summarize the data without losing information. So very stupid example. So here we have 2 pigs. Now, maybe this one is way heavier and not so easy to achieve such a high quality, but we also don't want to end up having such a quality of a pig. So with descriptive, you kind of try to get the closest thing to this without having exactly this. So you don't manage to have the whole population, but you try to just get a part of it, and hopefully though, it is representative of the whole. Inferential goes a step further. So once we have our sample, we want to be able to make conclusions about the whole population. So we don't only check how the people in the group that we are looking at are behaving. So for example, we might check the people that joined today, what is your grade at the exam? That's our sample. But maybe this is just a sample of a whole population, and the population is psychology students. So maybe based on your grades, we want to make conclusions about how psychology students in general perform on statistics. So it depends if we're only focusing on a tiny group or if we have a tiny group, but we want to make conclusions about a bigger group. We just can manage to get the information of all the psychology students in the world. That will be pretty hard. So eventually with inferential, we want to make predictions about the whole population. So we make inferences about the population based on a sample. So this is the big population, but we only have a tiny part of it. So only some of the people that belong to it. And again, it can be students, it can be mothers, it can be dogs, if you're doing the research on dogs. And the sample is whoever we observe, so the students of this specific course. And then inference is about making conclusions. So that's why inferential statistics, because it tries to make some inferences, which is conclusions about population based on a sample. So conclusion about the whole based on a part of it. Okay, so what are some fundamental things of statistics? Well, we have variables, and variable is just something that can take on various values. So x can be a variable, and it can be equal to 1, or it can be equal to 3. So anything that varies. We could have sample statistics. So just like we saw before, we have population and we have sample. And the sample statistics is a variable that describes the sample. So for example, here, these are all sample statistics. So basically, there are some numbers, some values that are about the specific sample that we selected, not the whole population, such as the mean. So whenever we see this x with the line on top, that's going to be the mean. And what does the mean say? Well, the mean, for example, could check of all the people that are here today, eventually what grade you get at the exam, then gives you the average. So it's going to take, I don't know, my grade, which is 8, and then do plus the grade of Barbara, which is 7, plus the grade of Indy, which is 10. So it sums up all of them. I hope those are good grades. And then it divides by how many people were there. So today we are, let's see, 51. So it's going to sum up all of our grades and then divide by 51. This way, we get a sample statistics, the mean specifically. So it says something about a specific group. But we also have parameters. And the parameters are variables about the whole population. So sample statistics, it's about the sample. The parameter is about the whole population. So instead of just wanting the mean of us all, we might want the mean of all the psychology students. So that would be then a parameter because it's about the whole population. And we're going to use the sample statistics to estimate the parameters. So for example, we're going to use the mean of our grades to estimate what the mean of all the psychology students could be. And it's important to say that we can calculate sample statistics, but we cannot calculate parameters. So the parameters, so the things about the population, are always just an estimation. The better the sample that we have, the better this estimation. Okay, so there's two big kinds of variables, so two big categories. We could have discrete variables, and those are all the integers. Now, kind of complicated word. I also didn't know it for long, or at least maybe I didn't know it in English, but it just means numbers that are whole. So nothing in between. So 1, 2, 3, not 1.2734, whatever. Only exact numbers. So 1, 2, 3, 4, 5, and so on. Nothing in between these. So these are discrete variables. And it could be the amount of students in a class. So hopefully none of you had 20 and a half students in a class. So I always think that you had either 21 or 20 people in your class. So the amount of students, it's a discrete variable. You're not going to have a 20.3 number of students in a class. That's not really possible. The number of likes on your Instagram post, I don't think any one of you ever saw that you had 73.3 likes. No. Again, you don't split the person into a third or something. Or we could have continuous variables, which then is all the real numbers. So all the numbers. So not just 1, 2, 3, and so on, but you could also have 1.37, 94.41234, and so on. So anything in between. All those infinite numbers. For example, length. So I can be 1 meter 69.33 centimeters tall. Or time. You also don't have exactly like 1 second, but you could have 1 second and 3 milliseconds. So all those things that you describe by putting basically a comma. And this is what the graphs look like. So we also have a distinction in how we are going to represent the variable. Now, if we have a discrete variable, we tend to have such a kind of distribution. So it's really very clear where the number is. So it's only gonna be integers. So 1, 2, 3, and so on. Well, with a continuous variable, we are gonna see a curve more than some lines, let's say. Why? Well, because it means the people really will be having any possible number. So anything in between any possible numbers. And this is why it looks like a curve area. Well, here it's more split. So, okay, you either scored 1, or you scored 2, or you scored 3. While here, you could literally have been scoring 2.5 or 2.52, 2.527, so literally anything. So you just draw a curve and then color it all. Okay, so just to go more into the details about how do we visualize the data, well, if we're gonna have discrete variables, it's pretty common that you might see either a bar graph or a pie chart. So these graphs are pretty most used ones when it comes to discrete variables because it's very easy to just show, okay, this is people that scored 42, this is people that scored 21, this is people that scored 13, and so on. Well, when it comes to the continuous, because again, they go also in between. So it's not just 21, 34, and so on, but you're going to see all kind of possible numbers in between. Then you might find a dot plot, a stem and leaf plot, or an histogram. But a lot of the times the histogram get just drawn like a curve. Okay, so also useful to kind of keep in mind. Say that maybe at the exam, they give you a pie chart, and then they're like, okay, what kind of variables were most likely part of the data? Discrete variables. Okay, so let's see one exam question together. So I'm just gonna quickly read it, and then what I always do is I give you all time to think about it, and you maybe can let me know whenever you're done thinking. So you can either type done in the chat, you can private message me the answer, you can use whatever emoji that you prefer just to give me a sign that you're done thinking. Okay, so Mario, yes, I'm Italian, so I'm gonna go very stereotypical. They're all Mario, sometimes they're Luigi, so that's it. Mario asks a group of students to come into his lab so he can measure the circumference of their heads. Although the students are a bit weirded out, they decide to go through with it. Mario calculates that the mean circumference of the student's head is 55 centimeters. He thus concludes that students in general have a head circumference of 55 centimeters. This conclusion is about a statistic, a parameter, or a sample. So take your time. If you need, also read it again, and then let me know whenever you're done thinking. Again, you can either type done in the chat, you can use whatever emoji, just give me a sign so that everyone has time to think and no one falls asleep waiting. For the reaction, I'm just gonna wait a bit more so everyone has time to think. Okay, so let's have a look. So the correct answer was a parameter. Now, why is it a parameter? So do you understand the difference between these three things, and then why would it be one or the other? So usually there's even maybe just one tiny thing in the text that help us understand who they are referring to. So for example, here we see that in the end, they make about conclusion the students in general. So it's not about the students that are coming into this lab, but it's about making conclusions of students in general. So basically we have a group of students, but eventually we want to make conclusions about all the students. So we have something and we want to generalize to a bigger group, which means a parameter. So we are working with inferential statistics. So we want to make inferences about the population. If it was a sample, then it would want to make conclusions about the student that came at his lab, not all the students. But here is really just taking the data, the circumference of the head of the students that came in the lab, but eventually we want to be able to talk about all the students. If they didn't say students in general, but students that came into the lab, then it would have been a sample. Is it clear for everyone? Perfect. Okay, so another exam question. So you're done thinking? So in the meantime, I'm also gonna reply to a question that I see in the chat. But if we wanted to measure this of the students in the lab, technically, wouldn't that be the population? Now, this depends. So if we only measured 10 students of the lab, but then the lab has 200 students, then yes, it would be the population students of the lab, and he only took a sample of them. But if he measured all the students that come to the lab, but eventually wants to talk about students in general, then you see it's only a group of all of them. So it really depends. Am I interested in all the students that come to my lab? And then, did I measure all the students that come to my lab or only a part of it? So it really depends on what was I interested in and how many I actually measured. So it could be a population, just like it could be a sample. So if I was interested only in the students that come to the lab and I measured all of them, then this is just descriptive statistics. So I measured everyone that I was interested in. But if I was interested still in the students of the lab, but I only measured half of them, then it's inferential because I only have a part of the whole. Just like, say that I measured all the students that come to the lab, but I'm interested in all the students. Then you see, students of the lab is only a part of all the students. Not all the students come to the lab. So it really depends on what I'm interested and what I actually measured. If those things are the same, so if what I was interested and what I actually measured correspond exactly, then that's descriptive statistics. So I don't want to generalize to something that I didn't measure. But if I only measured a part of the whole group that I wanted, then inferential statistics, because I want to generalize to something that I did not measure at the moment. So here, in this case, we had inferential statistics. So we wanted to make inferences about the population. Specifically, we measure students that came to the lab, but then we want to talk about students in general. Okay. Is it clear for everyone? I think so. Okay, so this was it about just the data. So very quick introduction, no numbers for now, just some things that we need to know by heart. So just knowing what statistic is, and then knowing specifically the difference between descriptive and inferential statistics. That's very important. and what changes between a sample and the population. So population is also whenever we work with the parameters. Sample, we have the sample statistics. Okay, so let's move on to the distribution. Now, potentially we could have a break, but you tell me, because yeah, we only have just an hour and a half, so we can also skip it. Depends if you're tired, if you need a coffee or anything. So you can maybe let me know in the chat if you do want 5 minutes break or you just want to continue. Yeah, I see no break. Perfect. Okay, so then we're gonna finish maybe a bit early. Okay, so let's continue. What about the distribution? So this is another fundamental part of statistics. And here, some calculations will come up. Now, what is the distribution? Well, simply the different values that we observe and how often they occurred. So my data, what exactly did I get? Okay, so which values? Well, let's say it's a grade at the university. It could be a grade of 7. It could be a grade of 8, 6.5. So those are my values. And then also how often they occurred. So this is what the distribution shows us. And it can be something like this. So imagine the grades. Maybe you see here, this is 7.5. So it means that these many people scored 7.5. These could be 10. These many people scored 10. Pretty unrealistic, I would say. But let's imagine that many people scored 10. So distributions are what we see in plots like this. So both of these are distributions. And again, it could be length, so how tall people are, the grades at the statistic course, IQ scores, anything. So anything that has different values that reoccur more or less. And the distribution just shows us which values were there and how many people obtained those values. Now, there are a few ways that we can describe distributions. First thing is pattern. So are there gaps? Are observations clustered together? So just checking if there's any pattern that we can see. So maybe we notice that a lot of people scored around 6, then no one scored 8, and then again, a lot of people scored 10. That's a pattern. So you see that you either do not so good or you do amazing. Or if observations are clustered together. So maybe we see that more or less everyone got a 7. So those are all things that we might want to notice. So those are some patterns. Or we could have mounts. Now, mounts is just a way of saying that basically we have like kind of like the mountain. So how many mountains in my graph are there? Well, it could be one, just like this one on the left. And then it will be called unimodal. So if we only see that there's one peak, then it's unimodal. Or we could have two, such as here. So we see that we have really a peak here and then another one here. So then it's bimodal. That's it. Nothing too difficult. So just checking how many peaks are there. If there's just one point that we really go all the way up and then down again, it's going to be unimodal. 2, bimodal. And the last thing is the shape. So what shape does our distribution have? Now, we could have a symmetric shape, so something like this. So we see that basically, if we were to draw a line here, it's kind of like a mirror. So it's perfectly symmetrical. So we're going to go from down, up, and then back down. So we have these two tails, let's say. So we have two tails and a peak here. And it's perfectly symmetrical. And the peak that we see here is going to be the mean. So that's where people on average score at the exam, maybe 7. So let's say here it's 7. So on average, the majority of people scored around 7. But we could also have a skewed distribution. Skewed means it's not symmetrical. And there's two types that we could encounter. We could have skewed to the left or skewed to the right. What does it mean? Well, if it's going to be left skewed, then the tail is going to be on the left. So skewed to the left means that the low part is on the left. So we go from low and then up on the right. Well, if it's skewed to the right, we're going to go from up and then down toward the right. So skewed to the left, down to the left, skewed to the right, down to the right. That's it. So try and remember, skewed kind of means down to. So skewed left, then it's down to the left. Skewed right, down to right. Okay. Now, the first three important things that we also have to know how to calculate are mean, median, and mode. And these are basically ways to describe the distribution by focusing on the center. So all of these three, mean, median, and mode, show us more or less where the center of the distribution is, but they do so in three alternative ways. Now, the mean is the most representative value, but only if it's not skewed. So the mean is the most representative value if we have such a situation. So if it is symmetrical. And the mean will be exactly here in the middle. And how is the mean calculated? Well, this is the formula. So we're going to see the x with the line on top. That's the symbol for the mean. And then what they say is basically that you have to take the score of each person, sum all the scores up, and then divide by n, where n is how many people, how many scores were there. So once again, here today we were 51. And let's say we all took the test already and we got our grade. If we take the grade of each one of us, we sum them all up, and then we divide by 51, we obtain the mean, which, if the distribution is symmetrical, so basically the kind of perfect mountain with the tip in the middle, then the mean will be the most representative value, so exactly here in the middle. What about the median? Now, the median is slightly different. It could be the same as the mean, but it could also be different, because the median is the middle value in a set of observations. Now, it's important to make a distinction between two cases. Whenever we have an odd or an even number of observations. Because if we have, like here, we have 5 numbers, it's very easy to find the number that's in the middle. That one is going to be 3. So this one no, this one no, the number that's in the middle is 3. So we're going to put them into an ascending order, and then the number that's in the middle will be the median. Okay, but if we have an even amount of numbers, then there's not really a number in the middle. So what is going to be the median? Well, the mean of the two most center numbers. So in this case, the two most center number would be 2 and 3. So we're just going to do the mean of those two. And that's 2.5. Well, if it was odd, very easy. We just see that 3 is exactly in the middle. And this is the most representative value if the distribution is skewed. So if we have such a situation, so we're going to see that the peak is not in the middle, but it's either to the right or to the left, then the median is the best measure to find out where the middle is. And the last one is the mode. Now, the mode is just the most frequent value. So let's say we have these 5 values here. The most frequent, so the one that we see the most, is 70, because there is just one 1, only one 5, only one 4, but there is 2 70. That's the mode. That's it. So the value that we see the most. Now, just to give you an idea, so why am I saying that, for example, the mean is the most representative and the best one to use if we have a symmetrical kind of distribution, but then the median is the best one if we have the skewed ones? Well, let's see what happens. If we have a symmetrical one, median, mode, and mean will all be exactly in the middle. So they are all the same numbers. So if we find out that the mean here is 5, the median and the mode will also be 5. But if we have a skew distribution, specifically, let's say is skewed to the left. So basically we slide to the left. So we go down to the left. Well, then what we see is that the mean is here. The median is here and the mode is here. So they are not in the same point. Now the mode is going to be the peak. Why? Well, because the mode is the most frequent value. And the peak is basically the scores that came the most. So it makes sense that the mode is still on the peak. But then the median is the number that's in the middle. And then that's a better representation of the middle of this distribution. Well, the mean, not so much, because what happens? Well, just because a lot of people scored on the right, then we see that the mean is not so much in the middle anymore, but it's kind of like moved a bit. And that's not ideal. So keep in mind, if you have the symmetrical shape, mean is best. Well, if you have the skewed, that can be either to the left or the right, then median would be the most representative kind of measure. Okay, see something in the chat. But why is the mean then better when the distribution is symmetrical? The median will be the same number then, right? Yes, they will be the same number. But the median is just telling you this thing is in the middle, but it's not really necessarily representative. So let's imagine this scenario. So let's imagine that we have a scenario in which we have 1, then we have 2, okay? Then we have 10, but then we have 1,000 and 1,001. Now, the mean would be 10. This is in the middle, but it's not necessarily the best representation. And also, yeah, the mean is always the best option because it's standardized. So also this keep in mind because we actually have a formula for it. So if you see the mean, we have a specific formula that we calculated with. While the median and the mode, it's simply about, okay, what numbers do I have? Okay, this one is the one in the middle. But it's not really that we calculate something. So keep in mind, if it is symmetrical, mean is the best. But you will obtain the same number. So you don't really make much of a distinction. But if they ask you, overall, mean is always the best to use because it's standardized. So it's also better accepted in research. But if it's skewed, then it's very important that you remember the median is better. So for symmetrical, doesn't really matter because they're all the same, but you would report the mean because it has more statistical value. But if it's skewed, absolutely the median. So very important. So at the exam, for example, pay attention. So if you see that they mention that we have a skewed distribution, then you know you want to calculate the median because that's a better indication. Okay, so let's just see now specifically for the mean. As we saw, this is one way that we describe the distribution, and that's by looking for the center, so the middle of it. We saw that this is how we calculate it, and the thing that we see here is simply saying we need to sum up all the x's, so all the observation, all the grades of students, and then divide by n. And n is sample size. So the total amount of observations that we summed up. Pretty straightforward. An example, say that people scored 3, 4, 1, and 3. So we have these 4 people, and those are their scores. What are we going to do? Well, we're simply going to sum these 4 scores up and divide by 4. This value that we obtain is the mean. What about outliers? Now, this is one thing that we need to pay attention for. Outliers are just extreme values. So if we were looking here, say that the last person, instead of scoring 3, scored somehow 68. So we're going to have all the people scoring pretty low, so around 1, 3, 4. And then you have a 68, which is kind of problematic because then what happens to the mean? Well, the mean changes a lot. So it's not going to be 2.75 anymore, but now the mean is 19. So maybe that's not ideal. That's not really so representative of what's happening. And this happens whenever we have a skewed distribution. So then, wouldn't it be better to use something else instead of the mean? Yes, we said that if it's skewed, the median is better. Why? Well, if we were to use the median here, what would happen? Well, the median would simply be where we are in the middle. And that's going to be between 3 and 4, so 3.5. And well, that's definitely more representative than actually doing the mean, which will give a lot of weight on this 68. So this is why the median would be better if you have a skew distribution. Okay. Now, just a very quick exercise. We're going to walk through it together. So let's say we have the numbers 1, 4, 68, and 3. So just like we saw in the previous slide. And there's 2 steps that we want to do. So if they ask you to calculate the median to make your life easier, do these 2 steps. First of all, you want to order the numbers because it can be likely that at the exam, they don't already give them in an ascending order. Just like here, they might say 1, 4, 68, and 3, which is not so evident to see where the middle is. So we're going to first order them from the lowest to the highest. So we're going to put 1, 3, 4, and 68. Once they are written like that, we need to find where the middle is. And here we have to make the distinction. Do I have an even or an odd amount of numbers? Well, in this case, we have an even amount of numbers because we have 4 numbers. Then the median is the average of the 2 middle numbers. In this case, 3 and 4. So the median will just be 3 plus 4 divided by 2, 3.5. Otherwise, the other situation, we have, instead of an even, we have an odd amount of numbers. Even easier, the median is just the middle number. And the middle number here is 4. So once again, first step, put them in order. So that makes your life way easier. Second step, understand, do I have even or odd number? If I have odd number, I just pick the middle number. So 4, very straightforward. If they are even, before picking a number, make sure that you do the mean of the 2 middle numbers. So 3 and 4 here. Okay. I hope it's clear. Now, let's move to the probably most complicated topic of the day. And this is another way that we can use to describe the distribution. So for now, we saw the mean, the median, and the mode, which are about the center. So the most representative values. But otherwise, we can also focus on variability. And variability is basically how spread the values of the distribution are. Kind of like saying, okay, how far from the middle my score is. So checking how much is the distance between the average. That's the variability. So how far from the center the scores are. And there's a couple of ways that we can use to describe. First of all, deviation. And that's also called deviation from the mean. So literally checking how much an observation, a score, differ from the mean. For example, if we look here at this graph, let's assume that the mean is 4. I scored here. Then this part in red is going to be my deviation. So I am this much far from the mean. And how is that calculated? Well, you just are going to take your score minus the mean. So if I scored here 0, let's say, I'm just going to do 0 minus the mean of 4. So minus 4 is my deviation from the mean. This is how far I scored from the average. Or we could have variance. Now, variance is something that starts from the deviation from the mean, but then you kind of make some additional calculations. And it tells you how much the values are spread around the mean. So the concept is pretty similar, but it makes it more like a standardized kind of description. And it's in general about the whole distribution. So it's not only about my score compared to the mean, but it's about, in general, how far people are from the mean. So what we're gonna have to do is some additional steps. So you see that there's the x minus the mean stay the same. So this part is the same. So we're gonna start that for every person, we're gonna have to do the difference of their score and the mean. So this is the same. Let's say at the exam, I got an 8 and the mean is 7. I'm just gonna do 8 minus 7. That 1 is my deviation from the mean. And that's this part here. Okay, what else do we see? Well, we see the 2 on top there. So basically that tells you, once you have the deviation, you're gonna have to square it. So I found out 1, and then I have to square it, which also gives me 1. But let's say instead of 1, I scored 10, and the mean was 7. Okay, then I do 10 minus 7, which gives me 3. And then I need to square that 3. So basically doing 3 times 3, which gives us 9. Okay, what else do I have to do? So after I calculated my deviation and I squared it up, what do I have to do? Well, we have once again this symbol. And if you remember from the meme, this symbol tells you sum them all up. So for every person, we're going to have to calculate the deviation, square it, and then sum all this number up. So for example, here, this person scored 1, so we're going to do 1 minus 4 squared plus 2 minus 4 squared plus 0 minus 4 squared plus, and so on. So for every single person, we do these steps, and then we sum up these numbers. The last thing we need to do in order to obtain the variance is divide by n minus 1 though. So not just n, but n minus 1. So the sample size, the amount of people, minus 1. And keep in mind that the variance is going to be shown as an S with a 2 on top. So if you see S with 2 on top, that is the variance. Last thing is the standard deviation. Now, if we look closely, they are basically the same. The only difference is that we see the square root here. And this is also why the standard deviation will just be an S. So the variance is the S with the 2. Without the 2 on top, it's standard deviation. What is the big difference? Well, that the standard deviation is going to be the same number that we obtain with the variance, but we need to do the square root of it. So let's say that we obtain a variance of 4. What is the standard deviation then? Well, square root of 4, which means 2. It also means that we can go the other way around. So let's imagine that they tell us this distribution has a standard deviation of 2. And then at the exam, they ask us to calculate the variance. How do we do that? Well, if to go from the variance to the standard deviation, we do the square root, to go the other way around, it means that we're going to square it up. So if I know that the standard deviation is 2, I just square it and I obtain 4. And that's the variance. So the square root of 4 gives me 2. Squaring up standard deviation of 2 gives me 4, and that's the variance. So you see, the only difference here is this square root. All the other steps are exactly the same. Now, why would we use the standard deviation? Well, it's easier to interpret because it's standardized. So it doesn't depend on the original measurement unit that we selected, centimeters, kilograms, whatever. It's just standardized. So it means that it can be compared even if we use different measure units. So it's pretty handy. And the n minus 1 that we see here at the denominator, it actually has a specific name, and that name is degrees of freedom. So n minus 1, meaning the amount of observation minus 1, is called degrees of freedom. So if you ever find that at the exam they write down there were 18 degrees of freedom, that 18 is simply the result of doing 19 minus 1. And 19 was the sample size. So degrees of freedom is sample size, so the amount of observation, minus 1, n minus 1. And it refers to the number of independent values that can vary in the calculation. And in the case of a sample, it's always calculated by taking the sample itself, the n, minus 1. So pretty handy. If we know the sample, we also know the degrees of freedom. It's just sample minus 1. And if we know the degrees of freedom, we just know that if we add 1, we obtain the sample. So pretty handy. Okay, so let's check together one exercise. So how do we calculate these things? Let's say we keep track of our friend's grade and want to calculate the standard deviation. Little weird, but we are very curious. We want to, I don't know, feel better about ourselves. So we always check if we, obtain better results. Because we are a little weird, we only have 3 friends. Maybe because we want to keep track of their grades, but yeah. And together, the grades of us and our 2 friends are 6, 7, and 8. Now, we could calculate the standard deviation of this set. How? Let's see together all the steps, because I know that sometimes it's hard to picture when you see the formulas, but once we see it with numbers, it's relatively easy. Okay, so this is the formula. So this is the formula for the standard deviation. Let's break it down. So I advise you to not put everything in the calculator at once because, well, actually sometimes calculators cannot handle it. So if we have a lot of scores, you might reach a point, and I did reach it myself because I was too lazy to try and do the steps. And after putting so many numbers into the calculator, I just realized that you actually have a limited amount of space. So I just couldn't put any more scores, and I had to redo everything. So try and break it down. How? Well, first of all, we need the mean. So if we look here into the formula, we see that we need the mean. If it's not given to us, we have to calculate it. Well, these are the grades that we have, 6, 7, and 8. How do we calculate the mean? Well, we're going to do 6 plus 7 plus 8, and then divide by n. How many is n? Well, 3. We have 3 grades, 3 observations. So we just sum them up and divide by n. Okay, 7. That's our mean. The next step is to calculate the deviation and then square it. How is that done? Well, we're going to have to do it for each person. So we're going to start with the person that scored 6, subtract the mean, which is 7. So we just saw that it's 7. And then we square it. So 6 minus 7, we obtain minus 1. If we were to square it, we obtain 1. And here, pay attention because it's very important and it's quite a typical mistake. Whenever you are going to square, you also need to square the symbol. So if you have minus 1, then also the minus gets squared. And a minus squared will give us a plus. So keep it in mind. Say I have minus 2, I don't obtain minus 4. I obtain plus 4. So pay attention with the symbols. So once we do this squared thing, we're always going to obtain a positive sign. Then we do it also for the second person. So we're going to do 7 minus 7 for the mean, and then square it. 0 squared, still 0. And finally, also for the last person. So 8 minus 7, and then squared. Okay, what is the next step in the formula? Well, we're going to want to sum all these square deviations up. So we're going to take 1 plus 0 plus 1. That's it. We obtain 2. So this is everything that they say you have to do at the numerator. What about the denominator? Well, we have n minus 1. What was n? Well, n is 3. So how many scores, how many observations we have? Minus 1, we mean 3 minus 1. And the numerator, we had already calculated it. So 2 divided by 3 minus 1. 2 divided by 2, it gives us 1. Now this would be the variance, because if we remember, once we saw the formula before, without the square root, that's the variance. But here, we want to calculate the standard deviation. So once we have done this, we're just going to do the square root of 1, which in this case is still 1. So also the exam, really pay attention of what they're asking you. Do they ask you the variance or the standard deviation? Because if they ask you the variance, then once you have calculated all these, you stop. But if they ask you the standard deviation, then you also need to do the square root of it. Okay, I saw something in the chat. Let me see. I didn't quite get the degrees of freedom. Could you explain again, please? Yes. So the degrees of freedom is simply n minus 1. That's it. It's just another way to call it. So instead of just always saying n minus 1 is, they might write in your exercise, the degrees of freedom is 2. Okay, that simply means that to obtain that 2, they did n, the sample, minus 1. And the degrees of freedom is kind of like how much variation is there. That's kind of the concept. But the important thing for you to remember about the degrees of freedom is that it's n minus 1. So saying n minus 1 or saying degrees of freedom is the same thing. So if they come and tell you the degrees of freedom were 20, then it means that n, so the sample, was the 20 plus 1. So we had 21 people, and if we do 21 minus 1, we obtain 20 degrees of freedom. Okay, is this clear for everyone? Are there any other questions? Okay, good. Then let's continue. Okay, so the standard deviation, we saw how to calculate them, and they are very helpful for normal distributions. What are normal distributions? Well, the symmetrical ones, sometimes also called bell-shaped curve, because if you look at this one, it kind of looks like a bell. So that's about it. So it's symmetrical, it's a normal distribution, or bell-shaped curve. And why are standard deviation very helpful here? Well, because there are some empirical rules that will tell you that whenever you do have a normal distribution, so this kind of shape, the 68% of scores will be within -1 and +1 standard deviations from the mean. So basically in this area here, there is 68% of all the scores. While between -2 and +2 standard deviation from the mean, so the area here, that's where the 95% of the observation will be. So it means that out of all the people, 95% of them will have scored in between those. And then from -3 to +3 standard deviation, that's 99.7. So almost everyone will be within those. So this helps you understand how many people actually scored that. So it says, okay, 68% of the people scored at most this far from the mean. 95 at most this, and basically everyone at the most they scored something as extreme as this one, but no further than that. But keep in mind that these rules only apply for normal distributions. So this is very important. So if at the exam you see that they show you a skewed distribution, so not symmetrical, not bell-shaped, but maybe it has a very big peak on the right and then it goes down, and then they say 68% of the people scored within -1 and +1 standard deviation, then that's false. So you need to pay attention. This only applies with the normal distribution, so the symmetrical one, not for the skew. Okay. Now, one last very important thing is the z-score. Now, a z-score will tell us how many standard deviations an observation falls from the mean. So if we look here, basically, -1 standard deviation, that could also be represented by a z-score. So the z-score will tell you how many standard deviation away from the mean you are. And how is it calculated? Well, to calculate a z-score, we have to take the score of the person. So back to the exam, let's say I scored an 8 and the mean is a 7. I'm gonna have to do my grade, 8, minus the mean 7, divided by the standard deviation. And that's my z-score. So it's a very standardized measure that helps us immediately understand how far we are from the mean. So how many standard deviation we are far from the mean. And we can calculate the z-score for all the observations. So every person will have an individual z-score. So I scored 8 on the exam, and then I put my score of 8 minus the mean and so on. But then there might be another person that scores 6.5. So then the person will have a z-score that's calculated by doing 6.5 minus 7 divided by the standard deviation and so on. So everyone gets a z-score. And the z-score are just another way to standardize. So we create a standard, which really helps because this way we can compare between samples. So once we have standardized results, these allow us to compare people that are even from different samples. So people that we didn't really measure at the moment. Now, the z-score can be positive or negative. What is the big difference? Well, we're gonna have a positive z-score if the observation is higher than the mean. Now, if I scored an 8 and the mean is 7, I do 8 minus 7, 1, divided by the standard deviation, it's still gonna be something positive. So positive z-score just means that I scored higher than the mean. And it's gonna be on the right side of the distribution. So let's imagine here is the mean. The z-score is gonna be on the right if it's positive. Well, it's gonna be on the left if it's negative. And negative means then that it's lower than the mean. So pretty handy. Positive, higher than the mean. Negative, lower than the mean. Okay, so just to remember, this is very important. There's the distinction between sample and population. Now, statistics describe the sample, while parameters describe the population. And also, they're pretty easy to find because parameters will always be represented with Greek letters. So you will see, for example, here, this kind of like the O. That's the way to show the variance, if it has the 2, or the standard deviation without the 2, or the population. While if we refer to the sample, hence statistics, we're going to see the Latin letters. So basically what we have written in every single slide. So like an X or the S. Yes, I see something in the chat. Are z-score for normal distribution only or also skew graph? Z-score are also for normal distribution. Yeah, because they are a standardized measure. So that's also kind of the thing. Whenever you see standardized, then it means that it's, yeah, normal distribution usually. Okay, and keep in mind, we're gonna use the statistics, so things from the sample, to estimate the parameters, so the population. And this is just a different way. So if you're gonna see the X with the line, that's the mean, but for the sample. Well, if you're gonna see this Greek letter here, then that's the mean, but for the population, so it's a parameter. The S with the 2 is the variance of the sample, while the kind of O omega with the 2 is the population, so parameter. D, S, so just S, standard deviation of the sample. The symbol, just like that, the standard deviation for the population. Okay, and we use this one to estimate these, because these we can never know. We only estimate them thanks to the sample. Okay, let's continue. Now, one last thing that we want to check is position. So a final way to describe distribution is position. So basically telling you where is my score compared to other people. So how did I score compare, I don't know, to my friend Josh? And we could use percentiles, and percentiles basically tell you that if I'm talking about the 18th percentile, that means that 80% of people had this score or lower. So if we look at our distribution and we find that, let's see here. So let's suppose that here is the 80th percentile. Then it means that this part of the curve, so all of these, so everything before here, is 80% of the people. So 80% scored lower than that point. This is simply what it means. While the 20th percentile means that 20% of people scored that score or lower. We could have quartiles, and quartiles will be, well, the first quartile is the 25th percentile, meaning that 25% of the people score that score or lower. Second quartile is going to be the 50th percentile, which is also the median, and basically tells you that 50% of people score that score or lower. Then you have the third quartile, which is going to be here, and then it's 75% of people, so 75 percentile. And well, the quartile 4 would be here, and that would be 100. So basically, we're just dividing the data into 4 equal sections. And that's it. The last final thing is the interquartile range, which is just doing the difference between quartile 3 and quartile 1. So here is quartile 3, and here is quartile 1. So we do the difference between those two. And here is in the middle the median. So the difference between 75th percentile and 25th percentile. Okay, and keep in mind that quartiles and box plots, so this one is a box plot. So whenever you see that you're gonna have this line and then like a box in the middle, so a square in the middle, and they are pretty handy whenever we have outliers. Because this way we can really see like, oh, wait, basically everyone scored here, but there's only just 3 extreme people that scored all the way there. So it's not that the distribution actually goes from -3 to 3, but it's just these 4 people that scored crazy like that. The majority of the rest of the people go from -1 to 1. So it's very handy to check that. And important though, because we have outliers, we don't really work with the mean, but with the median. So the one that's in the middle, because if we have outliers, it means that we are going to have a skewed distribution. So the mean, it's not so representative. But the median, yes. And with the box plot, that's indeed the one that they show. So in the middle, between the first and the third quartile. Okay. Now, what was the goal for today then? Now, you might remember we saw the aliens in the very beginning. So now, before finishing everything for today, let's have a look at this one. And then there's also another exam question for us to have a look at it together. So what was the exam question that we started with today? And now I want you to try and calculate it. So make sure you have the calculator or your phone. So we had aliens that landed on Earth, and they were pretty chill. Mario made some friends with them and measured their IQ. And these were the IQ that he found. So these 5 numbers here. And the question was, what is the standard deviation of this set of observations. So take your time, and I really advise you break it down into all the steps that are needed, and let me know whenever you're done thinking. So what is the standard deviation here? And then we're gonna loop together. And then there's one more exam question. Okay, I see some reactions. I'm gonna wait a tiny bit more, and then yeah, make sure you let me know when you're done. Also, if your brain is just too fried already from statistics, you just can't, that's also fine. Just let me know. I know it can feel a bit like a scam. You didn't think you signed up for these once you start psychology, but I assure you, will get better. Okay, I think we can start having a look. And don't worry, this is one of those things that you really just have to practice a bit. So it's not that complicated, but I get that there's quite the steps to be done. So it can be a bit confusing in the beginning, especially to remember. But if you just do a lot of exercises, it just becomes like driving a car. At some point, you don't just go and think about, oh, wait, I need to put my feet there and then I need to check the windows and blah, blah, blah. It just comes automatically. Okay, so let's see. Now, the correct answer was 11.22, but how do we get there? So this is the formula. So first of all, we need to understand that they ask the standard deviation and not the variance. So is the one that has the square root. And how do we calculate it? Well, I really advise you to break it down into pieces. First of all, get the mean. So we're going to sum up all the IQ scores and divide by the amount of IQ scores that we have, which are 5. Once we have the mean, we're going to have to do the deviation from the mean squared for each one of these IQ scores. So we're going to take 167 minus the mean and then squared. 169 minus the mean and then squared. 180 minus the mean and then squared. 181 minus the mean and then squared. 195 minus the mean and then squared. And very important, keep in mind that also the minus gets squared. So here, after these steps, you should have only positive numbers. Okay, the next thing is to sum them all up. So we're gonna take these 5 numbers that we obtained and we just sum them. Okay. Now we need to calculate basically the variance. So we're just gonna put this number and we divide by the degrees of freedom. So n minus 1. So 5 minus 1. Very last thing, we have to do the square root. And if we do the square root of the variance, we obtain the standard deviation, which was 11.22, more or less. Okay, so is this clear? I know that there's like a lot of steps, a lot of calculations, but they are not complicated. So here it's really important that you pay attention to not make mistakes in the calculator. I think that's the most common mistake, just copying one number wrong on the calculator and then everything goes to shit. So really pay attention to having the correct number on the calculator. Are there any questions about this one? Okay, so pay attention, variance or standard deviation. And then remember, the variance would be without the square root, standard deviation with the square root. So just that further step. Okay, so before we move on to the final question, obviously, as you know, this is just a free training and we only have 1 hour and a half. So as you can expect, the full training is not going to be this short because I don't think even Eminem could just rap through statistics in just 1 hour and a half. So it is a bit longer. And there you will go through all the topics. So not only the chapters that we covered today, but everything else that's important for the course. You're going to have a lot of exam questions from previous exams. So it's pretty handy also to just exercise or a good way to revise before the exam. And there will be small groups for the full training. So today we were 50, so that's a lot, but usually you're always around 10, 15 in the full one. So they try to make a lot of groups so there's space for everyone's question. And there's a 24/7 WhatsApp group. So there you can ask any questions that you might have. And yeah, you can find on the Athena website, so probably the same place where you signed up for this one, you can find the full course. Otherwise, there's also the fat cat with the times and dates that you can check. Let's do something in the chat. Are we covering all necessary topics for the exam in the crash course? Yes. So in the crash course, you will be covering all the topics that you need to know in the exam with some tips and tricks on what to focus on, how they might phrase the exam questions, and obviously you are free to ask any questions there about everything. Okay, so before the last question, I need to ask you if you could fill in an evaluation form. It's very, very fast. It only has 5 questions. and you have to basically just rate it with numbers from 0 to 10. Obviously, I would want to be rated as high as possible, so like a 9 or a 10. But if you don't think it's a 9 or a 10 yet, there's also a feedback part that you can obviously leave some comments on. So it's always handy both to know if there's any point of improvement, if you enjoyed it. So feel free to either scan the QR code on this slide, or you should have gotten an ink via the email, or also on your Athena profile. So I'm just gonna wait a tiny bit. Maybe let me know when you're done. And I swear, it's very, very fast. It's just 5 questions. You just put the tick on the number that you want. And yeah, so like it's not a 9 or a 10, then you can also just leave any tips for improvement. So that's always very nice to read. Okay, so I think someone put the link to the whole course. I think so, yeah. I think it looks like the correct link. So yeah, perfect. Which chapters were covered? So I'm also gonna go back for that for 1 second. So we start in the beginning with the exam analysis. So we covered these 2 years, the chapter 1 and 2 of August. Okay. And everything else will be covered in details in the full training. I think there was also another question. So before moving on, I'm just gonna check that one too. And if you still haven't, please fill in the evaluation form. Um, will there be a discount code for the full course? Now, usually yes. So I haven't heard, but I can ask. So if it's something that you all would be interested in, I can definitely ask and come back to you maybe in the WhatsApp group. So I think that could be handy. So I'll definitely try and ask and see what I can do. Okay, so I'm waiting for more reactions. So did you all fill the evaluation form? Then I can move on. And then you're free to enjoy the rest of the day at least. Okay, I see some reactions. What about the others? Yeah, and yeah, if for whatever reason it's not working, you're always free to just fill it in later on. And yeah, any comments is always very much appreciated. Okay, so let's move on to the last exam question. Now, after measuring the aliens, Mario goes to his supervisor to proudly boast about the fact that he calculated a standard deviation by hand. Sir, look at this beautiful number. Mario's supervisor, who is also a bit of a prick, dramatically points out that standard deviations are not just a number, and tells Mario to stop embarrassing him by not using the right terminology. What word should Mario have used instead? So would it be parameter, statistic, or distribution? Okay, I'm seeing some reaction. I'm gonna wait just a few more seconds. So what is standard deviation? Okay, so statistic. Now, why is it statistic? Well, because it's about the sample. So it just measured those 5 aliens that he had at hand, but it's not like he measured every single alien that exists. At least I hope there's not only 5 aliens in the whole world. So yeah, that's what he measured, and that's why statistics. So it's about the sample. Parameter would have meant that It's the whole population, so every single alien that there is. Okay, so parameter, population, statistics, the sample. Okay, so this was it for today. So we covered the data, we covered the distribution, and yeah, I hope it was useful for you and you didn't hate it too much. I know it's statistics, but still, thanks guys for some clapping. Okay, do you have any questions? Anything that's still unclear? Okay. Then, well, I wish you a nice day and good luck with your lectures and exams and all. Maybe we'll meet again.